let's do introduction to backend development with Flint Dart. So first we need to know what exactly is backend development. Number one thing to think about backend is to think about backend as a data management. A data management that is like a brain box of your application, the one that handle all data retrieval, storage, and manipulation. So backend that handle all those things. So we cannot think as backend as business logic. It processes all the core rules and operation that makes your application unique, from complex calculation to other improvement and user interaction. You can also see backend as a seamless communication between your front end, your user interface, with the system, the real system. You can see backend as that communicates with your user interface and with you, or the way your what applications to do. So now, example of a backend is your Flutter display a product, while Flint Dart backend securely manage products and list user orders, user account, and so on. So why do we need backend? Before we look at why we need backend, we need to look at what front end alone or Flutter app alone cannot do, or any front end alone cannot do. Front end cannot store user accounts and profiles, and front end cannot process secure financial transaction or payments. Front end cannot effectively manage and query large data sets. And so now let's look at what backend or what backend enables us to do. It enables us to save a persistent data, to save its information a long time. It allows us to have what is called a security and authentication to protect user data and control user access. And also front-end, backend also enables us to handle multiple users at the same time. So now let's understand what is called HTTP, the web language. HTTP, or Hypertext Transfer Protocol, is a fundamental protocol for communication in web. It is a set of rules that allow your front end and back end to talk to each other. So every time you open your application or you visit a website, there are HTTP requests that are flying up and front. So this is how it works. Front end will call on HTTP, call on backend and say, hey backend, can I have a latest product list? Backend will say, sure. Here is the data in JSON format. So backend will now send data to the front end, so then we present it to the user or to the client, anybody using it. Now let's look at this like this. So front end application, which is our Flutter application, will make a request to HTTP request through the Flint Dart API. Flint Dart API will communicate with database and check the data in your database, take the data back, we respond back to the request, and Flutter application will receive the request. So now your Flutter application will send a request and wait for a response from Flint Dart. Flint Dart will receive the request from your Flutter application, do what is expected of that request, and respond back to the caller. So let's look at indefensible database. The backend needs a dedicated place to store all the application data permanently. So this is where database comes in. Imagine a database, a library of your application information, where users, products, messages, payment record, and more are stored. Without database, your application will simply disappear. Every time you run on your server, you will restart your server. So, or your application close, your application will simply disappear. So it's like database is like the memory of your application. So database ensure data integrity and allow effective or efficient query and provide a structured way of managing a vast amount of information. So let's look at the type of database that we have. We're going to look at what's called a relational database and non-relational database, which is SQL database and NoSQL database. So this SQL database is a database that have a organized data, or that organize data into a table with predefined schema. They are excellent for structured data where consistency and integrity are paramount. So now let's look at, and the example that we have for that is MySQL, Progress, Oracle, and SQL Server. So NoSQL database are offer flexible schema, making them suitable for unstructured or semi-structured data. They are ideal for rapid development. Maybe your data application change over time, so you can actually use what's called MongoDB or Firebase. So now let's look at what Flint Dart support. That provide a robust support for MySQL and Progress out of the box, giving you powerful option for your data storage. Now let's look at common HTTP requests. So HTTP requests are not just a one-size-fitting. The different action on the front end translate to specific type of request sent to the backend. These are often referred as a CRUD, which is create, read, update, and delete. First request type, get. Get is used to fetch or retrieve data from the server. It read only and does not modify the server state. Now, we have what is called a post request. It's used to create a data on the server. The data is included in the data, or the data of the request is included in the request body. We have post, on the other hand, and patch. They are used to update existing data on the server. Put or usually replace the entire resources, which patch partially update it. We have another one called delete, used to delete data from the server. So now, and let's understand what is called middleware. Middleware. Think of middleware as a security checkpoint. They actually put a series of interception points that stand between front-end requests and back-end call logic. It executes before the final route handle runs. So before when you send your request to your backend, there's what we call middleware that will first of all check what you are sending to us. Maybe it is error or anything like that. Maybe I want to hack us. You want to check that first. Maybe you are authenticated or you are not authenticated. Check you first before it allows you to go into the endpoints. Now, middleware can be used for different things. It can be used for authentication to check if user is logged in or authorized to do some certain thing. It can be used for logging a request, for analyzing and debugging, and it can be used for validation to ensure that incoming data are correctly formatted or valid, or cross-handling to manage cross-origin resources with share policy. So you find that you can easily add specific middleware to your route or to your group route, to your route or group of routes to protect or process a request. And let's look at how backend flows. Let's assume that a user logged in, that is. So when he logged in, he make a request, like you want to log in now. You make a request to Flint Dart API, and Flint Dart API process the request. They receive the request and check the database and see what is actually going on. When they check that, he look at the validation, like you validate the credential. Maybe whenever you get the database, maybe you send your email and your password. You take the email from the database and you check it with your password. If it's correct, it generates a token and it store the token install your token inside this thing. Inside, it generates token and respond or return the authorization token to the user. And Firebase or Flutter or any frontend store the token, and user are now logging into the application like that. And that's how the process of logging in flow works. Now, the next thing we need to look at is that why do we choose Flint Dart for backend? The one reason why we choose Flint Dart for backend is because of the familiarity of Flutter. Flint Dart is very familiar with Flutter. And then also a unified language. It allows you to write your front end and back end in a single language. And also it is very, very, very developer friendly. It comes with built-in feature like routing or different kind of thing like that. And also it gives you a full stack idea. So to embrace a real full stack, you use what's called that in all your contexts. And also it is open source and it's growing community. Now we use Flutter. Now let's go to Flint Dart. We just go to Flint Dart website and see what they have there.